going to apply those rules and that logic and those equations. As usual, I didn't leave myself a ton of room, but I'll squeeze it in on the screen and keep it as neat as possible. Given a series circuit, so even if the description here didn't say series, eyeballing the circuit, the fact that they're one after another, there's no breaks, there's nothing, there's no branches, I can tell that this is series. Typing this one up, the R1 was 2 ohms, so I'm going to put a 2, I'm going to put a 2 up here to help me remember that. R2 was 4 ohms, so I'm going to write a 4 ohms over there to help me remember that. Oops, a little bit messy. And R3 was 8 ohms. I just found a diagram of a resistor, of a circuit. It had been labeled with negative flow, and the people who had done their typing typed it as R1 at the top, R2 and R3. It doesn't really matter. It is kind of backwards. Electrons are going to go through R3, then R2, then R1, but we'll get the same answers as we work through. All right, so we've got a series circuit, a battery over here with a particular voltage. We'll get to that. Electrons leave there. They go through this thing called R3, which is 8 ohms, then the 4 ohm, then the 2 ohm, and work their way back to the battery. Equivalent resistance for a series circuit is literally just add them up. R1 plus R2 plus R3. I didn't leave myself much room. I'm going to squish it in here. 2 ohms plus 4 ohms plus 8 ohms. 2 plus 4 is 6. 6 plus 8 is 14. So my equivalent resistance is 14 ohms. What that number tells you is that maybe this is somebody's alarm system. Maybe this is an alarm system and you're a cat burglar and you want to kind of break into this. If you took all 3 of these resistors, maybe one is lights that are going to flash when the alarm gets tripped. Maybe one is bells that are going to go off, and I don't know what could be left, maybe more noisemakers. If you wanted to, if you're really careful, you could cut the circuit here and cut the circuit here and replace it with a single 14 ohm resistor, and the battery over here wouldn't know any different. As far as the battery was concerned, it would be the exact same thing. It would just keep pushing electricity around that circuit. That's kind of what equivalent resistance is. What could you replace all of those things with? And as far as the battery was concerned, the same thing's going on. So for this one, a 2 and a 4 and an 8, since they're in series, they add up to 14, so that's the equivalent resistance is 14 ohms. Moving on, if the voltage of the battery is 28 volts, to figure out the connection between voltage and current, we go back to that thing called Ohm's law. We just figured out that the equivalent resistance is 14. So the 14 can go over here, and the question I made up 28 volts, so the 28 volts goes here. I didn't leave myself enough room, but to get current all by itself, we have to do math and divide both sides by 14. 28 divided by 14, a little mental math, 28 over 14 is 2. So because of that equivalent resistance, the battery, 28 volts, is pushing through basically 14 ohms of resistance. By Ohm's law, that tells us that there'll be 2 amps of current. 2 amps will leave the battery, get to this corner and go around here. 2 amps will bump through R3, keep going through. 2 amps will get to the R2, bump through there, keep going. 2 amps will get to R1, bump through there and keep going. Because it's series circuit, the 2 amps is basically going to be everywhere in the current. Okay, last little bit, the power dissipated by R2. Maybe R2 was our noisemaker or something. Power in a circuit is current times volts. P equals IV. We just did that good work to figure out the current, so I know that I is 2. From the question, we were given that R2 is 4 ohms, so the power dissipated is going to be 2 times 4, which is 8, in the metric unit of watts.